Hello everyone, so the topic for today's video is method parameters. I'm going to be starting from scratch like you would be if you went into school and sat down at one of the computers that had nothing on it, just to make sure that we're all okay at this point. The first thing I'm going to do is go grab my GitHub URL for the course repository. So this is for IT 1050. So there's going to be my remote repository, so I have that copied. I'm going to open up Visual Studio. I'm going to open up my Team Explorer, say Manage Connections, and then I'm going to clone that URL that I just got. And remember, it can be any folder you want, but make sure you pay attention to where it's going to go. So once I hit clone, it pulled down everything from my remote repository, and I'm good to go here. So if I can just double click on my repository right here, and it will show me the solutions that are inside it, so I don't even have to bother doing file open. I can just double click on the solution that I want to open. So I'm going to double click on section 2 because I'm going to be adding to that. So I'm going to open up my Solution Explorer, and so now I can see in the Solution Explorer and the Team Explorer that I have my Section 2 solution open, and it's under source control. So any changes I make here, I can just come over right over here and commit them, sync them, and push them if I am happy with those changes. So for now, I'm going to close the Team Explorer. I can see here this is highlighted. That means that I have that solution open and it's under source control. So what I'm going to do for today is I'm going to add a new project to help explain method parameters. So I'm going to go to my solution, I'm going to add a new project. This is going to be example 5. Example 5 underscore method parameters. It's going to be a console application again. So I'm going to keep things simple at first. I'm going to go ahead and keep going with our person class example because I think we're kind of familiar with that concept by now. So my program is empty. I'll make that a little bigger. I'm going to add a class to my method parameters project. Add class. I'm going to name it person. And I'm going to say in my person class, I'll say every person has a name. Well, let's make it every person has a first name. Every person has a last name, and every person has an age, because that's what we've kind of been doing so far. And in the past, we would be able to write methods for this class that would say something like, I want to be able to ask any person to be able to give me their full name. So I could say public string get full name, and then I could return first name plus space plus last name. So we've already covered these concepts in the previous lectures, and if you want you could say this dot first name, totally optional, this dot last name. Notice how Visual Studio grays them out a little bit. That's showing that you don't really need to have that there. So let me just really quickly, since it only takes 10 seconds, once again exemplify how we use that. We can say, hey, I'm declaring a person, Donnie, instantiate that person. So now I have an object. I can say Donnie.first name equals Donnie. Donnie.last name equals Santos. And Donnie.age equals 37. And now I can say string full name equals, and now I'm going to invoke that method on my object, get full name. So just to recap, since this was the last thing that we learned, this stuff up here should be all pretty solid by now, understanding declaring the variable, instantiating the object. Now the variable has the address of the object, therefore we can use the dot to follow the Donnie variable to the object and access its public attributes. So this stuff should be pretty easy. This stuff we just learned. So when I say Donnie variable, take me to the object that you're pointing at, and get full name is a method, and its type, as defined in the class, is a string. So it's going to give me a string after it executes, and the way it executes is defined in the class. So this is the how it works. So that's a quick recap of method invocations. And then, of course, if I wanted to, I could say system.console.writeLine, full name, and just make it wait a second. So this should just print out my name. So that's good. So now, what I've been not telling you up until now, and this is kind of the last piece of the puzzle, I hope, is this business here with the parentheses. So up here when we were creating the person, I kind of told you ignore the parentheses. When we were invoking the method, I told you ignore the parentheses. When we were defining the method, I told you ignore the parentheses. Well, we're not going to ignore the parentheses anymore. So the parentheses is where you put the parameters. Now, a parameter is something, well, you could call it the inputs of the method, or in plain English, you could say the parameters are the things that you need to give to the method in order for it to be able to do its job. So the reason that this particular method has an empty parameter list is because if I go to a person and I say, hey, what's your full name? Well, they say, well, I know my first name and I know my last name, so I can go ahead and just give you my full name. You don't need to provide me with any additional information for me to perform that task. If I say, hey, you, what's your age? I don't need to know anything else. I can tell you what my age is. So you got to think of this kind of intuitively, like, I am a person. What behaviors can I perform? What tasks can I perform without any additional information? So I can give you my name, I can give you my first name, last name, age. I can do anything that is a combination of those pieces of information, as long as it doesn't involve something that I don't know. I don't need any parameters. But if somebody told me, for instance, hey, Donnie, I want you to add two numbers together. Well, I would be able to say, yes, I can do that, but in order for me to add two numbers together, you have to tell me what those two numbers that you want added together are. So these are the types of actions and behaviors where you need parameters. So let's actually use that example. Let's say we want to be able to have every person in the world be able to add two numbers and give you the sum. So we do it just like we did before, and clearly if we're asking somebody to give us the sum of two numbers, the return type is going to be an integer. So we'll name this method add two integers. So now it's time for me to make my return statement and give back somebody just asked me to add two integers, so what do I give them back? And this is the point where I can't go any further without my parameters. I have no idea what answer to give them if I don't know what the two numbers they want me to add are. The other confusing thing is this method, I have no idea who's going to call it. First of all, I don't know how many people objects there are going to be out there. And even if I do focus on a single person object, you could ask, in this case, we've created one object, Donnie. So let's say our program is so simple, we only have one person, and it's Donnie. We don't know if the program is going to ask me to add two integers once, or twice, or 0 times, or 1,000,000 times. And every time we ask Donnie to add two numbers, it could be with two different numbers. So we can say, hey, add 3 and 7, now add 12 and 15, now add 1 and 17. And we can keep going on like that forever, asking to add two integers with different integers. So we have to specify these parameters kind of abstractly. And the way we do that is by using formal variable declarations. So as you can tell by what I said, variable declarations, that it's going to look just like a variable declaration as we've been doing, like up here. A variable declaration is always the type, followed by just any name that we can come up with. So we're going to need two formal variable declarations in the parameter list, the first number and the second number. So I'm just going to go ahead and type it out, and then I'll explain what it means. So int x, comma, int y. So by saying int x, comma, int y, we've formed what we call a comma-delimited list of variable declarations. For example, I can keep going on forever. I can say int x, int y, int z, int a, string s. I can keep declaring these formal parameters forever, but you need to know exactly how many you want and what you should name them. So in this case, we know, based on our intention and also the name of the method, that we want 2 parameters, and both of them are probably going to be integers because it's called add 2 integers. And I can name these things anything. They don't need to be x and y. I can say the first number and the second number. So a new programmer might want to see variable names like this, and a more experienced programmer might understand method parameters so well that they want shorter names like x and y. But let's do it like this for now. So now the way that this method looks to me, the way I'm reading it, is it says, okay, I'm a method. I'm going to give you back an integer. The name of the method is add 2 integers. But in order for it to work, the person asking for this behavior, for this action to actually happen, has to provide 2 integers. You can't say, hey, Donnie, add 2 integers and here's a 7. That doesn't satisfy the needs or the inputs that are required for this method to run. They have to say, here's an integer 7 and here's another integer 10, for example. But since these are variable, that gives us the ability to say, well, we don't know what the numbers are actually going to be, but we'll refer to them by these variable names for the purpose of the function, or the method. Function, method, it's kind of the same term. So the way we treat this is, okay, somebody asked me to add 2 integers, and whatever numbers they gave me, this variable, the first number, that's going to represent whatever the first number they gave me was, no matter what it was. And this is going to represent the second number they gave me, no matter what it was. So now my job becomes actually doable. I'm not painted into a corner here where I don't have the information I need. I can say, oh, they gave me 2 numbers, so I'm just going to return the first number plus the second number. Oops. So now the method hopefully makes sense. It says, I'm going to give you back an integer, and you're going to give me 2 integers before I even get started. And whatever those are, that guy and that guy, whatever the values of those are, I'm going to add those together and return the sum. So now back here, I can do something like string, I can say int sum1 equals Donnie dot add 2 integers. And now notice, I'm going to do that again. When I invoke the method, I'm going to do this a little slower here. So as soon as I say Donnie dot, it takes me to the Donnie object, and it lists all of the methods available to me and the properties available to me. And there is my method. And notice when I highlight it, it shows me the whole, this is what we call the method signature. So it doesn't show me the code inside of the method, like how it works, but it does show me the return type, the name, and the parameter list. Because I need to know that out here. I need to be able to say, oh, okay, to call this method or to invoke this method, I need to give it 2 integers. So what I see when I look at that is I'm getting an integer, and I need to give 2 integers. So I'm going to call that, and the moment, be very slow with this. The moment you hit the first left parenthesis like this, boom, that thing's going to show up again, and it's going to highlight the current parameter that you're on. So that's basically saying, hey, give me a number. So I'll start off by just saying 7. I'm going to hit 7, and then I'm going to hit a comma. And now it highlighted the next parameter, which is the second number, also int. So it's saying, hey, give me another int. So now I'm going to say, I'll give it an 8. And now I'm just going to put a semicolon to end my statement. So this is also a method invocation, just like we were doing before. The difference is I'm putting values inside of the parentheses. This method had an empty parameter list. This method required 2 integers. So what's going to happen here is it's going to invoke this method and pass these 2 values, as soon as I ask it, hey Donnie, add these two integers using the parameter values of 7 and 8, and these are not abstract formal parameters, these are actual values. It's going to say, okay, I'll be right back. Let me take this 7 and this 8, and I'm going to jump over to here, and I'm going to use the 7 and the 8 as the value for that and the value for that. So this is going to become return 7 plus 8, and say, okay, let's say now I'm done. It'll jump back to here. This whole thing will say, okay, I'm done. I got returned the value of 15. And we can keep doing this all day long. We can say sum2 equals Donnie.add two integers. Now I want to add 2 and 3. And hopefully I should get back a 5. If I want to do it again, let's say add 2 integers, and I can say add a 1 and a 9. I can keep doing that all day long. So I'm going to go ahead and write those out just so we can see that they worked. Not that we need to write them out, but we'll do it anyway. So let's debug this and watch it in action. So I'm going to put my breakpoint here. I'm going to run my program. So I'm going to go ahead and step over these and watch my locals populate with values. Created Donnie, gave him a first name, gave him a last name, gave him an age. So inside of my Donnie object, there's my values that I expected to see. Again, now I'm going to use F11, or see up here this little arrow, step over. We've been using F10. If you use F11, which is step into, instead of just turning this invocation into the value and giving it back to you, it will actually help you dive into the method and show you what's happening in there. So F11 is step into, because you want to see the details of the method as it's invoked. So it says, oh, this is a string, but I need to go actually figure out which string I'm computing. So it says, be right back. I hit F11, dives in, and now I'm inside of the Donnie object. See, look, if I hover over first name, it says, I'm Donnie, my last name is Santos, my age is 37. And it's going to return Donnie plus space plus last name. So now here we are back in the main program, and you can see that the value of full name is Donnie Santos, just like we were doing before in the last lecture. Now here comes the new type of method with parameters. And it says, hey, Donnie object. Well, first of all, this add two integers method is an integer. So this whole thing is going to give us an integer. That whole highlighted area is going to give us an integer that's going to go into the variable sum1. But to see how it's happening, I'm going to dive in with F11. Donnie.add two integers, it's going to pass a 7 and an 8. So I dove in, and once again, I am inside of the Donnie object. I can see that down here. I'm inside of Donnie. Donnie's first name, last name, age. And I can also see the value of the parameters that I passed. See, now the value for now, while I'm executing this function, of the first number is 7. And the value of the second number is 8, because those are the values that were passed along with this particular invocation of the method. So it's going to return 7 plus 8. And we'll see that sum1 is now 15, which is exactly what we expected. So now if I'm going to dive into this next method, and again, we're inside of the Donnie object because I asked Donnie to perform this action, but this time the values are different for the parameters because I passed a 2 and I passed a 3. So this time it's going to return a 5. Notice sum2 got the value of 5. Once again, I'll dive into the third invocation. Same object, Donnie, different values for the parameters, 1 and 9. It'll return a 10. And I'll just step over those so I can see them printed out to the screen. Donnie Santos, 15, 5, 10. Beautiful. So that's cool. The second part of this, though, that I want you to understand is that, I mean, you've probably already gotten the picture, but the methods are being invoked within the context of an object. So let's say I simplify all of this. Let me get rid of, I'll just keep it. Let me say, I'll put it down to 2 sums. I'm going to actually create another person. So I'll say it's my brother. Oops. Let's see, how old is my brother now? Oops. I think he's 29. Alright, so now I have two people. So this is where it gets interesting. I am going to create two of these. You know what, I'm going to get rid of this. I really want to make this very clear, so I'm going to trim this down. I'm going to get rid of that parameterless method altogether. So what I want to exemplify here is that I'm going to ask Donnie to add two numbers, and then I'm going to ask Michael to add two numbers. So I'll ask him to add a 10 and a 5. I'll ask Donnie to add a 10 and a 5, and then I'll ask Michael to add a 20 and a 5. And you know what? Just let's ask them to add the same exact two numbers. I think this is going to clarify what I'm trying to get across. So first I'm asking Donnie, hey, add a 10 and a 5. So he's going to give me sum 1, and then I'm going to ask Michael, hey, Michael, what's 10 plus 5? And he's going to give me the same answer, right? So let's debug through this and watch it happen. Put my breakpoint here. Run it. I'll go ahead and step over all this instantiation and variable setting, and now down here we can see that the Donnie object and the Michael object are both created, two different people with different values inside. So here's where I want to make my next point. So just like before, I'm going to dive into the method add two integers that I'm asking Donnie to perform. I'm going to hit F11 to dive into the method. And the first number I pass the value of 10. The second number I pass the value of 5. So obviously it's going to return 15. And it does. Sum 1 equals 15. Here's the thing. This time I'm asking Michael to add two integers, 10 and 15. I'm going to dive into that. So we still have a 10 and a 15, and it's going to return a 10 and a 5, and it's going to return 15. However, look where we are. If I expand this, now I'm not the same object. I might be invoking the same method, and I might be getting the same answer even. But pay close attention to the fact that this is a different object entirely that's performing the action, right? This is Michael. First name Michael, different age, completely different object performed the task for me. So yeah, maybe I got the same two sums, right? So why would I even point that out? The reason is because sometimes different objects calling the same method have different effects. So for example, what if I went back into add two integers and I said, before you return the first number plus the second number, do a system.console.writeLine this.firstName is thinking. So now what I'm doing is I'm saying, oh yeah, go ahead and give me the sum of the two numbers, but first print out the message that you're thinking about it. So this is going to be interesting because notice the first method I invoked, it said Donnie is thinking, and the second method I invoked said Michael is thinking. The reason this matters is because when you invoke the method, you can't just be thinking about the parameters. You also have to be thinking about who you are, what object you are, because you have access to all of the member variables of yourself. Just like I said before, if somebody asks me what my name is, I don't need any parameters because I know that already about myself. Similarly, inside of any method in the whole class, any given object that is currently invoking a method knows its own internal member variables. So that's the kind of the second aspect to this to understand. There's understanding the passing of the parameters, which is I think the easy part. And there's the understanding that you are a very specific instance of the person class during that invocation, and you have access to your own variables, which is probably the harder part to think about. I think I'm going to, maybe I'll do one more example. I was going to leave it at that, but I think I'll do one more example. Let's say I want people to be able to speak. So I'm going to say public void. This one's going to be void, so I'm not asking for a value. I'm just telling them to do something. I'll say speak. And I'm going to give one parameter. Because if somebody says, hey, you, speak, well, you might think of something to say on your own, but it'd probably be more useful if they told you what they wanted you to say. So, what to say. So, a person, you can basically order them to speak. You can say, hey, say this. That's what this is saying. So what I'll have this method do is I'll have it, let me just form a string, like an output string. And I'll say the output string is my first name plus, let's do it one step at a time just to make it less of a big string concatenation. So output is currently my first name, and then I'll append to the output using the incremental append operator. I'll append space to it, and then I'll append my last name to it, and then I'll append a comma and the word, actually, how about a space and the word says, comma, and a quote. Then I will put whatever they told me to say, and then I will put an end quote, a single quote. So basically, if I say, tell somebody to say hi, and I'm Donnie, it should show something like this. That's kind of the output that I'm looking for here. We'll step through it one piece at a time just to watch it work. So at the end, I'm going to say system.console.writeLine, and I'll just write the output to the screen. So now, this is kind of exemplifying what I was trying to get at there. So we'll go back to just the plain old add two integers. So with this example, we'll see how invoking a different object with the same method really has an effect based on the actual values of the member variables of the particular instance object that you're asking to invoke the method. So let's see. I will ask Donnie to say something. Speak. And again, the moment I hit the left parentheses, I see the parameter list that I need. It says, hey, you need to give me a string. So I'm going to have Donnie say, I am the smartest person in the world. And then I'm going to ask Michael to speak. And he's going to say, that is definitely true. So I'm going to Donnie's going to say something, Michael's going to say something, and then the program is going to be over. So let's watch this happen. It should be kind of interesting, I hope. Okay, so F10, 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 create our objects. You can see them hydrated with information. So now the fun part. So I'm going to dive into this invocation of speak, which is being done on the Donnie object. So the moment I hit F11, I am now inside of the Donnie object. Donnie is being asked to speak. The parameter value that was passed was I am the smartest person in the world. So I'm declaring a variable called output, and the value that I'm giving it is my own first name, and my own first name is Donnie because I am the Donnie object. So keep an eye on this output. So output is currently Donnie. Now I'm going to append a space. Keep an eye on the output. Now it has a space after it. Now I'm going to append my last name. Now I'm going to append space says, comma, space, quote. Now I'm going to append the value of the parameter, which was I'm the smartest person in the world. And now I'm going to append a single quote on the end of that. And now, the next thing it's going to do is our blank console screen is going to have an output on it. Ding. Donnie Santos says, comma, quote, I am the smartest person in the world, exclamation mark, end quote. So that's exactly what I wanted to see. Hit F10 to finish the method invocation, F10 onto line 18. Now I'm going to F11 dive into this invocation, and remember, now the Michael object is going to invoke this method with the string value parameter of that is definitely true. So now, look where I am. I'm inside of the Michael object. The parameter that I've received is that is definitely true. Declares the output local variable as this.firstName. At this time, this is Michael, because I asked a different object to invoke the method. Michael, add a space, add his last name, add a says, add the value of the parameter, add an end quote, and then print out the whole output, which is Michael Santos says. That is definitely true. So I think that, what's the word? I think that exemplifies all you need to know at this point about parameters. You need to understand that the parameter list is a comma-delimited list of formal variable declarations that will be given actual values when you invoke them, like I was doing before. I could say sum1 equals add two integers 7, 8. I can keep calling that many times with different values, like 1 and 9, or 2 and 13, or whatever. So that's the first thing to remember, is that you can keep invoking the method as many times as you want with different actual parameters for those, actual values for those parameters. Sometimes you say actual parameters, actual values. So each invocation can have its own different actual values. That's the first thing to understand. And the second thing to understand is once the method is doing its job, it's doing it inside of an actual instance. So the object that is performing and invoking the method matters. Donnie is invoking it, Donnie is invoking it, Donnie is invoking it, Donnie is invoking it, but this time Michael is invoking it. So you got to pay attention to two things. Which object is invoking the method, and what values are being passed to the method. So I guess the final thing I will say about that is, yeah, that's fine. The final thing I'll say about this is, actually you should have probably already figured this out, but the purpose of methods is code reuse. That's the primary purpose of methods. So now that I've said all people can add two integers and all people can speak, I can keep reusing that behavior forever and ever and ever. Notice I wrote all this code here. So there was like 1, 2, 3, 4, 5, 6, 7 lines of code. Well, now every time I ask a person to speak, it's reusing these 7 lines of code. So I could write a program that's creating 100,000 objects, 100,000 people, maybe like a video game or a student database or an employee database, and there could be people speaking thousands of times, all sharing the same definition for the method. And if I go in here and just change it once in the definition, it's going to, from now on, globally affect all of those places where the people are speaking. So there's one method declaration, and that is reused for every invocation of the method. Alright, so that was like 35 minutes. It's kind of hard to perfectly teach method parameters in one single video, but we'll see how you guys took to it. We'll talk about it in class, and if I get some feedback from you guys, maybe I can add another video or make some improvements or clarify some things, but I think this is good for now. I'm going to do one more on constructors in a few minutes, and then I will see you guys on Tuesday.